The air pollution of a city can be described using the function below, where t represents the time since 6 a.m. So the function is a of t, that is equals to 0.5 times t squared, and then times t minus 2, the entire quantity, raised to the fourth power, and then you add 30 to it. So since I mentioned the time, I have to give you an initial time. So the initial time is 6 a.m. So if you look at the inequality, when t is equals to 0, that stands for 6 a.m. and then the maximum is t equals to 12. So I am giving you a 12-hour time window. So that is from 6 a.m. to 6 p.m. So what happened when t is equals to 1? So when t is equals to 1, that is 7 a.m., t equals to 2, 8 a.m., t equals to 3, 9 a.m., t equals to 6, that will be 12 p.m. at noon, so on and so forth. The first question is, I would like to find a prime of t. So a prime of t means I am taking the derivative of the air pollution function. So when you take the derivative, so when we study derivative, so what's the first word that pops in your mind when I say derivative? So the word is slope, right? So when you just say f of x equals to x squared and you want to find f prime, so f prime is the slope. So most people will just think about the slope. But if you put this f of x equals to x squared, like if you're putting a function on an application problem, we don't just call it a slope, we call that rate of change. Okay, so the rate of change. So when you see the word rate of change, so this word means slope. So rate of change means derivative. So let's find the derivative. So we have a prime of t. Do we need to use some rules? The answer is yes. So since we have a t squared and then multiply a fourth power, so this is a product of two functions. So we have to use the product rule. And then for the fourth power, we have a linear function t minus 2 inside a fourth power. So there is a chain rule when you handle the fourth power. All right. So what's the product rule? So the product rule is fg prime plus gf prime, right? So a prime of t, so let's do the fg prime. So the 30, we can just ignore the 30 because when you take the derivative of 30, that is equals to 0. So fg prime, so we have 0.5 t squared. So here is comes to the g prime. So you take the derivative of this piece, right? So we bring the 4 down, and then t minus 2 to the third power, and then you have to use chain rule to multiply the derivative of the parenthesis, which is t minus 2. So the derivative of t minus 2 is equals to 1, and then plus gf prime, so g is t minus 2 to the fourth power, and then f prime, so you bring the 2 down, 0.5 times 2, that is equals to 1, and then 2 minus 1 is equals to 1, so you have a t to the first power. And then let's make a little note. So this is by a chain rule. All right, so let's clean up the coefficient. So we have a prime of t, that is equals to 4 times 0.5, that is equals to 2. So we have a 2t squared, and then times t minus 2 to the third power, and then plus t, and then t minus 2 to the fourth power. Oh, by the way, when you solve a rate of change and application problem, make sure the derivative is right, because after the first part is finished, every part following this will be based on the derivative function. So if your derivative is wrong, basically the entire problem is wrong. So imagine having this type of problem on a test that will maybe cost you 20 to 30 points. If you mess up the derivative, basically you are just tossing your 30 points away. So you will just get 0. All right. And then part B is find the rate of change, right? Find the rate of change. So I am using the a prime function, and then I need to plug in a few numbers: 8 a.m., 12 p.m., 3 p.m., and 7 a.m. So the first question is, for 8 a.m., do I let t equals to a? The answer is no. Take a look at the inequality one more time. So when t is equals to 0, there is an initial time since 6 a.m. That means when t is equals to 0, that stands for 6 a.m. So let's put this down right here. So they ask for 8 a.m. So they ask for 8 a.m. and then 12 p.m., which is noon, and then 3 p.m., and then 7 a.m. So 8 a.m. is 2 hours after 6, right? So that means t is equals to 2. And then 12 p.m. at noon, that is 6 hours after 6 a.m. So that is t equals to 6. And then 3 p.m. So based on 12, you have to add 3 more hours to it. So that is t equals 2. So or you can think about it like that. From 6 a.m. to 3 p.m., that is 9 hours, right? Or you can do a 0. I mean, you can do a 6 plus 9 hour, that is equals to 15. So if you use the 24 hour, 15 means 3 p.m. So this is t equals to 9, right? So that is 9 hours after 6 a.m. and then 7 a.m. So that is clearly t equals to 1. And then since they ask for the rate of change, do you see that? They ask for the rate of change. That means you have to plug in each of the t to a prime. So they ask for the rate of change of air pollution. So rate of change. So rate of change. That means you will be using a prime t, right? Because the a prime t is one function to describe the rate of change of air pollution in this city, using one function to describe the overall air pollution. So that is a prime t. So when t is equals to 2, so a prime of 2, that is equals to 2 times 2 square, and then 2 minus 2 to the third power, this is a 0, and then 2 minus 2, another 0. So overall, that is equals to 0. Since I didn't give you any unit, so you can say 0 unit per hour. So 0, so that means the 0, so the rate of change is not changing. So you can say the rate of change of air pollution is increasing at 0 unit per hour. So what happened when you plug in a 6 to it? So when t is equals to 6, you have 2 times 6 square, 6 minus 2 to the third, and then plus 6 minus 2 to the fourth power. So this is equals to positive 6144. The unit is unit per hour. So what does that mean? That means the rate of change of air pollution is increasing at this number unit per hour. So rate of change, the derivative, can be 0, positive, and negative. If the rate of change is 0, that means nothing is changing. Okay, nothing is changing. The rate of change is 0. So nothing is changing at that time. If rate of change is positive, that means the air pollution is increasing at that specific time. And if the rate of change is negative, that means the air pollution is decreasing at that time. All right, so a prime, the rate of change can be positive, negative, and 0. 0, no change. Negative, decreasing. Positive, increasing, just like the slope. And then a prime of 9, so that is 2 times 9 squared, and then times 9 minus 2 to the third, plus 9 minus 2 to the fourth. So that is equals to an even bigger number, 77,175. So this is unit per hour. So this is positive. That means at 3 p.m., the rate of change is increasing. The rate of change of air pollution is increasing. So if you are wondering why the numbers is so big, here is my answer. I just make up this function. Right? I'm not taking this function from any research paper. I'm just write a random function, for this problem. And then the last one is 7 a.m. So 7 a.m. is when t is equals to 1. So a prime of 1. So this is 2 times 1 square times 1 minus 2 to the third. So now we have a negative. And then 1 minus 2 to the fourth. So overall, this is equals to negative 1. Rate of change can be negative. That means the rate of change of air pollution is decreasing at 1 unit per hour at 7 a.m. Right? So decreasing means the rate of change is, the air pollution is going down at 1 unit per hour at 7 a.m. 0 means no change, positive means going up. All right, so that is the end of this video. If you think my instruction is helpful, give me a like, share the video for me, click the subscribe button if you are new to the channel. I will see you all in the next one. Signing out.